Within this world that we live in, 97% of the water is unavailable to the human species. But out of the 3% that is available, 2.997% is locked on icebergs and glaciers. The fact that we can only utilize 0.003% of the world's water supply barely stops the overuse of fresh water, as more and more water are lost from leaking taps and the amount of water used for cooking and drinking.
This notion that we'll have water forever is wrong. The world is running out of fresh water. In the last 10 years, major water companies from Europe have started taking advantage of pollution and scarcity.
Another fact that the human species do not consider is the man-made greenhouse effect. As on average, Americans drive 12,000 miles a year. As some of you know, 1 liter of oil can contaminate 2 million liters of water.
Who owns water? Who gets to make the decisions about water?
Although most agree,
water must be protected everywhere.
Some people still believe that it is okay to waste water.
It is a common resource. Water is not a property.
They're spending tens of millions of dollars to convince us that bottled water is better than tap water.
I think that this is the right way to treat the only 0.003% fresh water available to us.
No.
The users of the water supply, a town, factory, or just a building, need to have water pressure to maintain the safety of the water supply. If a water supply is not pressured sufficiently, it can cause many problems such as negative pressures. Negative pressures in the system may cause shallow groundwater to be pulled into a leaky water supply system, polluting it with microorganisms, dirt, fertilizers, and other toxic contaminants that may be in the groundwater. Because of the fact that water towers rely on the pressure produced by elevation of water from its gravity to push the water into domestic and industrial water distribution systems, it is required to have an electricity supply pump to refill the tower. The pump can fill the water tower up during the night, as the water level in the tower typically falls during the peak usage hours of the day. Firstly, water is collected from either surface water or underground water. It is collected by a pump, but however, relying on a pump to provide pressure is expensive. To keep up with the varying demands, the pump would have to be sized to meet peak demands. During periods of low demand, jockey pumps are used to meet these lower water flow requirements. The water tower reduces the need for electrical consumption of cycling pumps and thus the need for an expensive pump control system, as this system would have to be sized sufficiently to give the same pressure at high flow rates. Next, the water goes to the water tower. It could be sent to a reservoir, pump station, or water user. The height of the tower provides a hydrostatic pressure for the water supply system. Later, when demanded, water will be delivered to homes, buildings, and factories. And did you know that the Regional Peel operates and maintains 2,536 kilometers of sanitary sewer main, 34,510 manholes, sanitary sewer systems to the property line for all connected residential and commercial properties within the Regional Peel? Some of the maintenance activities performed by Peel are locating sewers, flushing, cleaning, televising laterals and mains, sanitary lateral and main repairs, manhole maintenance and repairs. And for more information about Peel water and wastewater, please visit www.peelregion.ca/pw/water. To test the efficiency of the two systems, we need the materials shown in the diagram, which includes 60 centimeters of plastic tubing, 1 liter of water, 1 2-liter bottle, a 500 milliliter beaker, a funnel, a pump, and a stopwatch, and a ruler, and a graduated cylinder. The first system only has one 90-degree turn in the tubing, while the second system has two 90-degree turns in the tubing, as shown on the diagram. And meanwhile, we're testing the efficiency of both. To test the efficiency of the two systems, we are testing the speed at which the water overflows through tubing and into a 500 milliliter beaker using a stopwatch. When the water reaches 100 milliliters in the graduated cylinder, we must stop the stopwatch and measure the time. As for the consistency of the water coming from the source, we are to use a funnel. When water is poured into the funnel, it provides a constant rate, therefore a fair test. In addition, we are also having 3 trials to test the systems. After completing the experiment 3 times for each system, this is our result.
As you can see, the graph shows that on average, System 1 is quicker than System 2 in transferring the overflow.
The first system took 6 seconds for it to fill up 100 milliliters of water, and the second system took 8 seconds.
Trial 1, 2, and 3 for System 1 shows an average of 6.1 seconds for overflowing 100 milliliters of water, while the trials in System 2 averages out to be 8 seconds.
Before moving on to conclusions, we can state that the reason for a quicker overflow response from System 1 was because it had less turns. Even with the same amount of tubing, System 1 on average has a faster and more efficient overflow due to more gravity force and less turns before entering the graduated cylinder.
The main objective of this lab was to investigate water systems, focusing on the water system used in Mississauga. The water that comes out of your shower or tap does not just appear magically, but through a system. Without the system, it would be very difficult for the public to get water, and if they are unable to obtain water, they will not be able to do many things. We investigated which of the 2 water systems worked the best, meaning which water system transferred 100 milliliters of water into the graduated cylinder the fastest, by using a stopwatch to time. We found out that the water system 1 is better with a time of 6 seconds, while water system 2 had a time of 8 seconds. In conclusion, we believe that the first water system was better because there was only one bend in the tube, giving a clear path for the water to travel into the graduated cylinder. The second water system had 2 curves in the tube, making it more difficult for the water to reach the graduated cylinder.